Hey guys, we're about to start graphing systems of equations. Now we've solved them using elimination and substitution, and I know you feel like we've been doing this forever, but we have to graph them because remember the solution that we've been finding has been an intersection point. And when we talked about that's where the graphs crossed one another. So the key there is they have to cross. We're trying to find where they cross. This is what systems is all about. So we're finally getting down to the nitty-gritty and we're going to do this thing, okay? So the sheet I gave you before we started this video is kind of a guide, and it's got graphs on it and the problems so that you can follow along and you can graph these systems as well. So if you will, just keep up with me and bear with me and we'll get this done. So I want to start with number 3. I know y'all hate it when I don't start with number 1. But I want to start with number 3 because these two equations are completely different from one another. Now remember, when we started graphing lines, we talked about slope-intercept form. And when we talked about slope-intercept form, you guys all know this to be y equals mx plus b. And remember, m is how you move, and it's your slope. And b is your y-intercept, and where you begin. And where the graph crosses the y-axis. Okay, and so these are all things that we've talked about before that you guys know, and you can just spout off to me at any given point at this point. So starting with this first equation, y equals negative 3/2 x minus 7. First we want to talk about what our b is. Our b is negative 7. This means the graph is going to cross the y-axis at negative 7. So if I go to my origin and I go and I count down 7, I'm going to end up right about here. Okay? And then my slope for this one is negative 3/2, which means I need to go down 3, 1, 2, 3, and over 2. Now remember, when we started talking about these, we said, hey, we can go back as well, up and back. So I'm going to go up 3, 1, 2, 3, and back 2. And I'm going to do this all the way across the graph. So you're saying, Ms. Blair, why do we have to do this many times? This is crazy. Well, what you're trying to find here when you do this is you're trying to find where the graphs intersect, remember? Well, what if they intersect way over here in this corner where I just put that last point? If that's the case, and you didn't put enough points across the graph, it's going to be very hard for you to find that line and that intersection point. So make your life easy to begin with and go ahead and graph all of those points, and you'll appreciate it later. So now, we've got one equation graph. Fabulous. So let's go ahead and let's graph the second equation. So we're going to have our b is negative 5. So it's right up here above this negative 7. And then our slope is negative 1/2. So that means we're going to go down 1 and to the right 2. Down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Okay, well, have I crossed that orange line yet? No, that's why we have to go up 1 and back 2. Up 1 and back 2. Now look at what we've done. Is our points crossing that orange line at this point? Yes, they are. We're making progress. So now, do our two lines cross? Yes, they do. Where do they cross? Well, if I look at my graph, and I'm trying to figure out where they cross, the orange and the red lines cross right here at this point. Now, it's not enough just to be able to graph these things. You still have to be able to tell me their intersection point, because that's what systems are all about. So looking at this point, I'm going down, or I'm going over to the left to the negative 2 and down to negative 4. So their intersection point is actually negative 2 -4. That right there is your final answer. So you have to be able to graph it and tell what their intersection point is. This is the solution to that system. So if you were to use substitution on this system, you would find that answer to be -2, -4. I'm not going to have you try it out because I know you can do it at this point. Now go over there and look at number 1. I want you to pay close attention to this one. If you look at the first equation, we have y equals 4x plus 1 for the first equation. So this one right here, the intercept is 1 and the slope is 4. Now if it's just 4, remember we put it over 1 and that tells us how many we're going to run because we already have our rise. So I'm going to start at 1 and I'm going to rise 4, 1, 2, 3, 4, and go over 1. Rise 4, 1, 2, 3, 4, go over 1. And then I'm going to go down 4, 1, 2, 3, 4, over 1, down 4, over 1, and then I'm going to draw my line because I ran out of room. So I'm going to draw a blue line through these points that I've drawn on my graph. Now looking at the next equation, what do you notice about the slopes? If you said those slopes are equal, Miss Blair, you're 100% correct. So my B is still different. It's -6. So I'm going to go down here to -6. And then my M is still 4, which I would put over 1. So I'm going to rise 1, 2, 3, 4, and go over 1. Rise 4, over 1. Rise 4, go over 1. Rise 4, go over 1. And I can go down 4 and back 1. Alright. So, my question is, where's the intersection point? There's no intersection point. That's exactly right. These lines are parallel. And remember, if we have parallel lines, that means the answer to our problem is that this system has, that's right, no solution. Okay? Now, what if we had graphed the lines and the two lines ended up on top of one another? What would we call those? If two lines ended up on top of one another, we would call them infinitely many solutions because they touch in infinitely many places. It's just like if we were to take two markers off of my dry erase board and we were to stack them on top of each other. They touch each other in infinitely many spots because they're lying directly on top of each other. So that's the first part of systems for you guys for graphing. Alright, I want you to take some time and I want you to practice.